The Pythagorean theorem is a fundamental result of geometry that concern the right triangle and express a very important relationship between the sides. In particular, it allows to obtain the measure of one of the three sides, knowing the measure of the other two sides. The theorem says that in a right triangle, the square built on the hypotenuse is equivalent to the sum of the areas of the square built on the sides. To understand the theorem, we draw a right triangle ABC rate in A and denote by A the hypotenuse, that is the side opposite the right angle, and by C1 and C2 the two sides that are called the catetus. And we built on each side of the triangle a square with the base of that sides. The area of the square Q, constructed on the hypotenuse I, is equal to the sum of the areas of the square Q1 and Q2, constructed on the two catheters C1 and C2. Referring to the figure, the sum of the area of the green portion and the blue portion is equal to the area of the red portion. In formula, Q equal Q1 plus Q2. Remembering that the area of the square is obtained by squaring the measure of the sides, we have Q equals I squared, Q1 equals C1 squared, Q2 equals C2 squared. We can enunciate the Pythagorean theorem using the following formula. I squared equals C1 squared plus C2 squared. This relationship between the catetus allows us to quickly derive the inverse formulas of the Pythagorean theorem. C1 squared equals I squared minus C2 squared. And C2 squared equals I squared minus C1 squared. So, to understand the theorem, let's do an exercise. The problem says, of a right triangle ABC, rate in A, we know the length of the hypotenuse BC and the catetus AB. BC equals 5 cm and AB equals 3 cm. We want to find the length of the catetus AC. So, we don't know which is the major catetus and which is the minor catetus, but that's not a problem. We know that BC is the hypotenuse I, and AB is the catetus C1. We know I and C1. So, we use the third formula written to calculate C2. The formula is C2 equals the square root of I squared minus C1 squared. In this way, we found the measure of the other catetus C2, and we were able to understand which of the two catetus is the major one.